Here is a useful form of the second law that is useful for engineers, the Clausius inequality. This is a small integral equation, but with
Ini
t
kelas
intermediate.
perbiasamaan
Please don't get irritated by this equation. We will conduct a physical experiment to understand. The Clausius inequality means that if you take a cyclic process, such as in a refrigerator, and add all the heat interaction happening at the boundary divided by the temperature at the boundary, the resulting value will be less than or equal to 0. This is an interesting equality, which is true of all cyclic processes. To make this equation more application-oriented, let us introduce a new term, the famous term of entropy. Entropy has two parts, one to represent disorder and another to describe the heat transfer effect. Here is a common myth buster. Entropy is not only disorder, but it has one more part within it, that of heat transfer. In short, entropy change of a process can be defined as the sum of change in entropy production and entropy transfer. For a perfectly reversible process, where the process has no friction in mixing, the entropy production becomes 0. If you use this definition of entropy in the Clausius inequality, we can prove mathematically that during a spontaneous process, the entropy of the universe always increases. This is known as the increase in entropy principle. This is a very useful form of the second law. Now let's take a practical case to understand this principle better. Consider this hot tea problem. We want to find out whether the hot tea will absorb or release heat. The tea is the system, and everything except the tea is the surroundings. Assume the tea is absorbing heat, a heat of 10 J. So entropy change of hot tea is 10 divided by temperature of the hot tea. The same heat amount is lost by the surroundings. So the entropy change of surroundings is minus 10 divided by the temperature of surroundings. If you add these two quantities, you will get the entropy change of the universe. It's a negative quantity in this case. This is impossible due to the second law. Now, assume the hot tea is losing heat. So Q will be minus 10 in this case.
Pasti
You can see
ada
that the
kehilangan
entropy change
panas.
of the universe is positive here, and this is possible. So using the
Seperti
second
kita tahu
law of
kan bikin kopi
thermodynamics,
dari
we
panas,
have proved that the hot tea can only release heat, and it
kondisi
cannot
lingkungan
absorb.
lebih rendah dari temperatur kopi,
Now let's get
maka
back to the
dibiarkan
chemical
akan
reaction problem.
memproduksi entropi sebesar
Assume the
itu.
reaction has happened and the system's entropy is increased by delta S, and it has absorbed some heat. We call it enthalpy. What we have to calculate is the entropy change of the universe. We already have the entropy change of the system here. What will be the value of the entropy change of the surroundings? Here's a small clue for that. If the system has absorbed some amount of heat, the surroundings have same heat amount is lost by the surroundings to the second law. The hot tea can only release heat, and it cannot absorb heat. Increased by delta F. What we have to calculate is the entropy change of the universe. We already have the entropy change of the system here. What will be the value of the entropy change of the surroundings? Here's a small clue for that. If the system has absorbed some amount of heat, the surroundings have lost the same amount of heat. So the entropy change of the surroundings is negative delta H divided by T. Thus, you can easily represent the entropy change of the universe as this. If this quantity is greater than 0, then this reaction is feasible. Now, let's have a rearrangement of this equation. Since the temperature T is always positive, if I multiply by minus T, the inequality equation will become like this. When this term is less than or equal to 0, this process is possible. We call this new term Gibbs free energy, or in simple words, the change of Gibbs free energy of the system is less than or equal to 0, then that process is possible. This is the advantage of using Gibbs free energy. Unlike the increase in entropy principle, you need not to worry about what is happening in the surroundings. You can concentrate your study only on the system. This way, you can predict whether a process will be spontaneous or not. We hope from this video you have developed good insight into the second law of thermodynamics. Thank you for watching the video.
Baik, ada pertanyaan sampai di sini? Silahkan.
Pak, izin bertanya, Pak.
Boleh, silahkan.
Kalau konsepnya untuk kalau yang panel surya itu gimana, Pak? Itu kan konversi juga, Pak.
Konversi juga. Ya, energi yang masuk itu energi dalam bentuk foton, ya, diserap dalam sel surya, kemudian ketika konvek menjadi energi listrik, karena ada beda potensial di situ, ya. Nanti saya ini kan videonya ada ya, ini ada bukan saya buka dulu. Ya, surya. Ya, saya lihat di YouTube ya.
Bebasnya bayar pakai apa aja, nomorin juga.
Langsung kiri dong.
Cepetan belanja di rumah. Nggak pakai lama.
Ibat. Oh, Ibat
The
loh.
most commonly used renewable energy source, photovoltaic or PV system, about 0.5 to generate usable solar cells connect and can be used to achieve cell work. The generation of electricity on exposure to sunlight is known as the
In the last 2 decades, the contribution of solar energy to the world's total energy supply has
Nah, ini ada ya. Kelihatan nggak? Tadi siapa yang bertanya tentang solar cell? Prinsip kerja solar cell.
Saya, Pak Raihan.
Oh, kelihatan nggak?
grown significantly. This video will show how solar cell or
Halo, Jackson,
Ya, Pak.
kedengaran suara saya?
Terdengar, Pak.
Nah, oke ya, tadi nggak stabil.
Terdengar, Pak.
Nah, ini kelihatan nggak tampilannya?
Terlihat.
Saya dari YouTube ya.
And absolutely freely available energy on planet Earth. In order to utilize this energy, we need help from the second most abundant element on Earth, sand. The sand has to be converted to 99.999% pure silicon crystals to use in solar cells. To achieve this, the sand has to go through a complex purification process as shown. The raw silicon gets converted into a gaseous silicon compound form.
Nah, dari
This is
silika
then
ya,
mixed with
makanya
hydrogen to get highly purified polycrystalline
proses
silicon.
menjadi polikristalin silikon. Ya.
These silicon ingots are
Ada
reshaped
tipenya
and
macam-macam, ada
converted into
mono,
very
ada
thin
poli.
slices called silicon wafers. The silicon wafer is the heart of a photovoltaic cell. When we analyze the structure of the silicon atoms, you can see they are bonded together. When you are bonded with someone, you lose your freedom. Similarly, the electrons in the silicon structure also have no freedom of movement. To make the study easier, let's consider a 2D structure of the silicon crystals. Assume that phosphorus atoms with 5 valence electrons are injected into it. Here, one electron is free to move. In this structure, when the electrons get sufficient energy, they will move freely. Let's try to make a highly simplified solar cell only using this type of material. When light strikes them, the electrons will gain photon energy and will be free to move.
Nah,
However,
itu tidak
this
stabil
movement
pada
of the
saat
electrons
energi
is
dalam
random.
bentuk foton
It does not
menembus itu.
result in any current through the load.
Makanya di situ harus ada dua
To
material
make the
ya,
electron flow
supaya
in
ada
any
beda
direction,
potensial.
a driving force is needed. An easy and practical way to produce the driving
Ada,
force is a PN junction.
P
Let's
and
see how a
junction ya.
PN
Ada
junction
P
produces the
sama
driving.
N, kutub P
Similar
sama
to
kutub N.
N-type doping, if you
Kemudian
inject boron with 3
diinjeksi
valence
lagi
electrons
boron
into
gitu
pure silicon, there will be one hole for each atom. This
supaya
is called
terjadi
P-type doping.
aliran
If these two kinds of doped materials
supaya
join
jadi
together,
konduktor lah.
some
Gitu.
electrons from the N side will migrate to the P region and fill the holes available there.
Nah,
This
itu ada
way,
diffraction,
the
harus
depletion
ada
region
jarak
is
di
formed,
situ ya,
where there are
diffraction
no free
region
electrons
itu
in holes.
supaya
Due to the electron
apa namanya,
migration, the N side boundary becomes slightly positively charged. In the depletion region,
nah si elektron dari atas itu tidak bisa cenderung
drives
akan
the
ke
electrons
bawah
and
ya.
holes out of the depletion region.
Maka harus
Here we
ada
observe that the
konduktor lain
concentration of electrons in the
supaya
N region
apa
and
namanya
holes in the P region become so
terjadi
high that a
perpindahan
potential
energi
difference
dari
will
situ
develop
ya.
between them. As soon as we connect any load between these regions, electrons will
Nah,
start flowing through the
makanya
load. The electrons will
disambung dengan
recombine with the
kabel
holes in the P
konversi
region
supaya
after
jadi
completing their path.
apa
In this way, the
namanya
solar cell continuously
potensi
gives
stabil
direct
gitu
current.
ya. Tentu saja harus
In a
ada yang
practical
diubah di
solar
situ
cell,
ya
you can
menjadi
see that the top
energi
N
dalam
layer
bentuk
is very
cahaya,
thin and
energi
heavily
listrik
doped,
yang diubah menjadi
whereas the
cahaya.
P layer is thick and lightly doped. This is to increase the performance of the cell. Just observe the depletion region formation here. You should note that the thickness of the depletion region is much higher here compared to the previous case. This means that, due to the light striking, the electron-hole pairs are generated in a wider area compared to the previous case. This results in more current generation by the PV cell. The other advantage is that due to the thin top layer, more light energy can reach the depletion region. Now, let's analyze the structure of a solar panel.
Nah, kurang lebih begitu ya proses kerjanya. Cuma di sini ya itu yang jadi masalah itu rendemennya, efisiensinya masih rendah. Ya. Sekarang itu baru sekitar maksimum itu 20%. Tapi kalau kita real itu kita beli apa namanya modul TV itu ya, di sana speknya efisiensi 20%, mengubah energi cahaya menjadi energi listrik. Tapi realnya itu di bawah dari 15%. Kalau 15% itu masih untung, 12% itu. Kadang-kadang 10%. Maksimalnya itu segitu. Ya itulah kelemahannya ya dari EBT. Cuma di kita ini ya itu lagi dalam penelitian supaya efisiensinya lebih naik lagi. Ya. Gimana, Rehan? Ada pencerahan?
Iya, ada Pak. Mungkin harus didalamin lagi.
Ya, lihat lagi nih YouTube-nya ya. Nih, how do solar cell work? Gitu ya, di YouTube. Ya. Oke, paham ya? Karena ada dua material di situ, dua dua itu. Seperti kita tahu, kalau ada dua material disatukan, udah pasti dua tipe material disatukan, udah pasti di listrik ada beda potensial di situ. Ya. Oke, kita lanjutkan ya materi kita. Nah, Anda juga harus tahu dan paham tentang konsep reversibility ya, antara itu proses reversible dan irreversible. Reversible itu mampu balik ya. Jadi kalau dikaitkan dengan hukum kedua itu pasti irreversible ya. Reversible. Kalau reversible itu produksi entropinya sama dengan nol ya. Pasti sama dengan nol minimalnya. Ya. Ada 4 proses yang menyebabkan irreversibility, artinya ketidakreversibelan. Ya. Pertama, karena adanya friksi. Ya. Udah friksi, udah pasti ada kehilangan energi. Ya. Kemudian heat transfer, nah itu udah jelas itu irreversible. Ya. Tidak bisa dibalikin. Ya. Kemudian adanya throttling, pengecilan, penyumbatan, kemudian adanya mixing, ya, pencampuran. Nah, itu konsep irreversibility itu ada yang external irreversibility dan ada internal irreversibility. Jadi yang dinamakan dengan konsep external irreversibility adalah proses perpindahan panas yang menembus batas sistem. Ya, itu eksternal. Contohnya perpindahan panas dari sumber panas ke sistem boiler. Kemudian internal irreversibility. Ini akibat adanya gesekan di antara fluida itu sendiri ya di dalam sistem. Betul gesekan gas di dalam kompresor akibat adanya aliran gas. Suatu yang mengalir itu pasti bersentuhan dengan dindingnya, pengarahnya ya. Itu otomatis ada gesekan. Itu adalah pasti irreversible. Irreversible itu pasti memproduksi entropi ya. Pasti akan terjadi perpindahan panas. Ya. Nah, coba kita lihat konsep reversibility dulu ya. Kalau irreversible udah jelas ya, tidak bisa memburuk. Ini yang proses yang reversible, yang mampu balik. Seperti ini. Anda perhatikan videonya. Nah, ya, irreversible dan reversible itu. Nah, ini irreversible. Ya. Ya, ini water to ice to water, bolak-balik bisa ya. Kemudian lipatan kertas dibolak-balik bisa, tapi tidak mengubah substance, tidak mengubah zat kan. Volume tidak berubah. Ya. Nah, biji-bijian yang tumbuh di tanah itu menjadi pohon, menjadi tumbuh-tumbuh. Nah, ini adalah irreversible. Tidak bisa dibalikan lagi ke biji kalau udah tumbuh, ya nggak? Kertas yang dibakar itu tidak bisa dijadikan kertas lagi, udah. Itu yang namanya irreversible. Panas yang keluar dari boiler itu tidak bisa dibalikin lagi, ya. Mengubah pasta itu bisa nggak? Kemudian memasak telur juga itu berubah menjadi telur ceplok, ada telur ceplok balikin lagi ke telur dalam bentuk bulatnya itu bisa nggak? Nggak bisa kan ya? Itu yang irreversible. Oke, paham? Nah, ototrofi seperti yang itu dibahas lagi ya nanti ya. Nah, ini yang ada dari siklus Carnot ya. Ini mesin reversible ya. Ini yang mesin yang mampu balik. Katakan. Oke, sampai di sini ada pertanyaan, silakan. Lihat dari di situnya ya, di kampus itu ada apa namanya? Satuan pembelajarannya ya SAP, satuan acara pembelajarannya bisa dilihat gitu, ya. Jadi pertemuan berapa udah ada semua di situ ya, di agenda pertemuan ya. Di e-kampus sudah bisa absen?
Sudah, Pak.
Sudah, Pak.
Nah, ya.